Hello everyone. Welcome to Rushi Technologies. In today's session, we'll try to understand about what is log aggregation and log monitoring. Why log aggregation and log monitoring is very important when we are running our applications in a distributed environment. And with respect to this log aggregation and log monitoring, what is Elasticsearch, Logstash, Kibana, that is ELK Stack, and also we'll try to understand about what is EFK. Instead of Logstash, we can use other log aggregation or log collecting tools like Filebeats or Fluentd or Fluent bits like that. We have so many. So what is EFK and what is ELK? We'll try to understand. So let's assume you are developing, I mean to say your application team is developing applications. That applications can be developed in a monolithic architecture or a microservices architecture, that doesn't matter. And again, if that applications are being built and deployed in a virtualized deployments or a containerized deployments, right, we are going to deploy that applications into a virtual machines, in multiple virtual machines. And again, if it is containerized deployments, then we are going to run it as a multiple containers. Then we are using monitoring tools, that application monitoring and infrastructure monitoring. That application monitoring and infrastructure monitoring is different from this log monitoring or log aggregation. Let's say you are using that application monitoring tools or infrastructure monitoring tools like Prometheus and Grafana to monitor what is happening in our systems. We are going to collect the metrics. We are going to collect the metrics about our infrastructure where our applications are running. Metrics about infrastructure like a CPU metrics, memory metrics, storage metrics, network metrics, infrastructure metrics are a system metrics, and also application metrics. What is happening in the application metrics also you can collect. So in case if you are deploying your applications in a containerized deployments or Kubernetes, you can collect the Kubernetes metrics, Kubernetes resource metrics like pods details, deployments details, nodes details. So using that monitoring tools, we can collect the metrics, and based on the collected metrics we can create an alerts, so that if something is about to happen, let's say your server is running out of CPU, running out of memory, we can send the alerts or notification to the application team, support team, infrastructure team, so that they can proactively work on the issues before that is going to impact our customers or application. Suppose that similarly we are going to use Kubernetes metrics. If something is not working as expected in a Kubernetes clusters, like some pods went down, some nodes are down, some pods are not ready, and they are in crash loop backup or pending state for so much time, we can create an alerts. That is monitoring and alerting, like infrastructure monitoring and application monitoring, where we are collecting the metrics, and based on the collected metrics you can create alerts and send the notifications. And also you can visualize that metrics, and you can understand what is happening inside your servers, inside your clusters, or inside your applications like that. That is what the Prometheus or any other monitoring tools like Prometheus or maybe Datadog, these type of monitoring tools will help. So now this log aggregation and log monitoring is different. Let's imagine your applications are running, but when the application level issues, application something is not working as expected within that application code. So you deployed your applications and that applications are not working within that application code. There is some problems, there is some issues. Whether that applications are deployed in a virtualized deployment, whether that applications are deployed in a containerized deployment, maybe whether it is a single replica, multiple replicas, that doesn't matter. So what is happening inside that application, I mean to say, when the customers are accessing the application, request will go to the application process. The within that application there is some code. That code will be processing that request, and it will validate the request, it will take the input, it will validate, it will process, and it will give the response. So in that case, when any code or any application or any program is getting executed, what is happening inside, if you wanted to know, you are going to use some kind of a logging. Logs are very very important, your application logs. Suppose, let's imagine you take an application like Flipkart. Let's say some customers is going to access the application like Flipkart, and they will log into that Flipkart application. They are going to search some products, they are going to add some products, and they are going to try to make a payments. But in this process, somewhere the application is failed, somewhere the request is failed, somewhere the request is failed. So where exactly that request failed, why it is failed, what is the possible reasons, you need some kind of a information. We need some kind of a log statements or log messages. Just to give an example, if you guys are familiar with shell script. So whenever you are writing a shell script also, let's understand, whenever you are writing a shell script for adding simply to, you are adding simply to addition. Let's say you are having a shell script to have a addition. Let's say you are passing some kind of an arguments, you are passing some kind of an arguments to that function. Just to give an example, here you are trying to do addition, but what is happening, what input you are getting to this code, what output you, what is happening inside the code when this code is being executed, if you wanted to know, you are using echo statements, right? Like you are saying echo statement, you are saying add function is getting executed, just to give an example. And input, like let's say we have x value, just to give an example, what you have received, right? You will say something like this, y value, something like this is like a log statements, right? I mean, it's some kind of a messages you are building, messages you are trying to print. So you will say return value total, since total, like that you will do something. Just to give an example, this is like a log echo statements. So when you are running this script, right? When you are calling this script, when you are running this script, these messages will be printed so that it will be helpful. What is happening when that piece of code, when that piece of application or that piece of code is being executed? What is happening while running that code? If you wanted to understand, you will have these type of echo statements. Similarly, if applications are developed in Java, if applications are developed in Python, or if applications are developed in any programmatic language, that can be a dynamic web applications, or it can be a APIs, REST APIs, we are going to have a log statements or a log messages. We are going to have a log statements or a log messages, so that there are so many logging frameworks. There are so many logging frameworks. There is so many logging frameworks. Like if you are from development background, you can understand there is something called log4j. Using this log4j, that application team will write the log messages. It is, they are going to log the messages when the when that particular API is called, what is happening, right? Which condition satisfied, which other function is being called, what that is returned. Like that, these log messages are very very important. This is for troubleshooting the application issues. Troubleshooting the application issues. If you take any Java programmatic language, Python programmatic language, if you are from a development background, let's say you are going to use these type of log messages. Let's say we already have one application, right? If you see, I am talking about this one, log messages, information errors. Suppose this is also one code. This is also an API or code that can be a REST APIs. That UI, the UI will try to make a API calls like that. So whenever this API is getting called, we are like application team is going to have some kind of a messages. They are going to log the messages. These messages can be sent to the console, or these messages can be sent to the files. So console means that std out or std error logs. Files means these log messages will be stored in some file. So like that. In this these messages are going to be logged. So whenever any issues are happening with that application, so you can, for troubleshooting that application team or a development team, they can use these logs, what is happening, where request is failed, why it is failed, okay, if this is being failed, for what input it is failed, like that. This application team can have a log messages, like information messages, debug messages, error messages, like that. The application team will write these logs, right? Whether it's a Java code, Python code, whether it's a .NET code, or any other code also, there is a log messages or a log frameworks. This is like a echo statements in the shell script. Similarly, suppose you are let's say you are a DevOps engineer. You are creating a CI/CD pipelines. Let's imagine you are a DevOps engineer. You are creating a CI/CD pipelines. When your pipeline is being executed, what is happening? In which stage the pipeline failed? Why it is failed? If you want to know that information, you need a messages, right? You need that log messages, right? So this application level also there is a log messages, right? Now let's assume this application is going to be built and deployed in a virtualized deployment, containerized deployment, that doesn't matter. The end users are going to access that application via external, via load balancer, all those things. Request will come to application, maybe some or the other place the request is getting failed. Then as a application team, as a development team, we need that logs, that log messages, so that we can troubleshoot and we can understand, debug and identify what is the problem. But let's imagine whether it's a virtualized deployment or a containerized deployment, you are developing that, let's say this is application code, this is application code, that can be Java code, .NET code, Python code. Then you are building that application using some builder tools, whether you are manually building or CI/CD doing, that doesn't matter. Whether you are manually building or CI/CD building, that doesn't matter. Let's imagine this is your application code. This is your application code, app code, right? Then let's say this is your CI/CD processor, basically CI/CD tools or build tools, whatever your build process. Your build process. Let's imagine whenever there is a change in the code, right? Your build servers or a CI/CD servers, CI/CD, CI/CD servers. Your build servers or a CI/CD servers. Whenever there is a change in the code, they will take the code. They will pull this code, or manually you doing, or or that automatically you are doing. That doesn't matter, right? So let's imagine this is your, it is taking the code. Now all this build process, continuous integration process, like in case of Java code, compiling the code, or running unit test cases, executing unit test cases, right? All these things, executing unit test cases, and again checking the code coverage, using some tools like sonar cube. Then if everything looks good, you are creating a package, you are create you are building a package, creating an application package. And in case if it is a virtualized deployment or a containerized deployment, that doesn't matter. In case if it is a virtualized deployment also, you are creating an application package like this jar, var, eir, tar, zip, based on programmatic language. Again, if it is not Java based application, then there is no package. Then you will check, you will directly copy all that code as is, without compilation also, but you can check the code quality. Then this package, this application package, you are going to store into some artifactory. Like artifactory repository, artifactory repository. Whether you are manually storing, or whether your CI pipeline or continuous integration pipeline is pushing that package, that doesn't matter. This package will be stored into the artifactory in case of virtualized deployment. In case of containerized deployment, then in case of containerized deployment, here, then you are going to build a Docker image. And again, that code quality, code coverage reports, that code quality, code coverage reports will be part of Sonar Cube. Let's say this is a Sonar, like a SAST tool. I'm just giving example as a SAST tools like Sonar Cube, static application security testing SAST tools like Sonar Cube. That can be Java code or maybe Python code also. You can check the code quality, code coverage. This is where your code quality, code coverage reports will be there, right? If it is a instead of application, I mean say instead of virtualized deployment, maybe containerized deployment, you will create a Docker image. You are going to create a Docker image. That image will be stored. But let's imagine, even though it is a virtualized deployment, let's say this is your continuous integration process. Let's say this is your continuous integration process. Let's CI, continuous integration process, where all these things are happening. Any additional things also, if you want, you can do this. This is your continuous integration process. All these things are happening. Then you have a servers. You have a servers where you can deploy. Maybe that infrastructure team. The infrastructure team created a servers. Infrastructure team created a servers. That servers can be in on-premise environment. That servers can be in a cloud environment. That doesn't matter. Let's say this is one server. This is one virtual machine. That can be in on-prem or a cloud. That doesn't matter. Let's say this is one virtual machine with some capacity. That can be in a cloud like AWS, our EC2 instances, or that can be in on-prem servers. So this servers comes with some OS, some operating system. This servers comes with some OS again, some operating system. So here, in case if it is a virtualized deployment, you are going to install. And configure required application, required softwares, middleware softwares. So here you may install some middleware softwares. You are going to configure the server. You are going to configure the servers. You are going to do the configurations like required softwares. You are going to configure required middleware softwares like Java, Tomcat, and you are going to set some kind of a configurations or a settings, like some kind of a creating users or changing the some settings files like that. You are going to set a required environment variables. You are going to set a required environment variables here, right? And this is where you are going to deploy your application package. But as part of the regular sessions, we already covered. As part of our regular sessions, we already covered. Suppose if you in real time we are not going to deploy application in only one server, because it is like a single point of failure. So if something went wrong with that server, if something went wrong with this server, or if something went wrong with the application running in the server, or maybe even though server is healthy, application is also healthy. Let's say there is so much a traffic or a request comes to that application. Again, if that server doesn't have enough hardware resources, again your application may run out of CPU, memory, storage. Again, it's a single point of failure. So in real time, we are going to replicate this application into multiple systems. We discussed about scaling, horizontal scaling, vertical scaling as part of regular sessions. And we already know what is vertical scaling, what is horizontal scaling, what is what like that. So we are going to replicate that application into multiple instances, multiple servers. Again, instead of manually creating the servers and instead of manually doing a configurations, again there is some other tools in DevOps, like configuration management tools, infrastructure management tools like that. Suppose if we are using a cloud, like AWS or Azure or GCP, even on-prem also, instead of we manually create a required infrastructure like a servers, storages, networks, that infrastructure resources, instead of manually creating a required infrastructure resources like a servers, storages, networks, in cloud like AWS, Azure, GCP, on-prem also, we can define our infrastructure also as a code using infrastructure management tools like Terraform. And again, instead of manually creating an infrastructure also, you can create our infrastructure also as a code using Terraform, right? And again, in that infrastructure, instead of manually doing the configurations, if required, you can use the configuration management tools like Ansible. So what is Ansible, how Ansible works, all those things also we have discussed now. But let's understand we have deployed this application. Then via pipelines, via continuous deployment pipelines like Jenkins, or maybe you can use Jenkins, or maybe you can use GitHub Actions, or maybe you can use other CI/CD softwares like we already know Jenkins. Now here we are going to bring a load balancer, and again all these application instances will be in a private network. We are not going to expose them this to the internet. So VPC, private subnets, public subnets, like that. So now let's say here we are going to bring a load balancer. That load balancer can be a software load balancer. That load balancer can be a software load balancer. Load balancer, that's load balancer can be a software load balancer, or a hardware load balancer, or a cloud managed load balancer. Cloud managed load balancer. So we can bring a load balancer. The load balancer will distribute the load or a traffic to the multiple backends here. So let's say we are going to bring a load balancer. So what is this load balancer? What is reverse proxy? What is load balancer? Right? How this works, we already discussed, and there is a video also. There is a video also in our YouTube channel. There is a video also in our YouTube channel. So we are going to bring a load balancer. That load balancer will distribute the load. Let's say, one second. Let's say this is the load balancer. This can be internet facing load balancer for customers from internet end users. So this load balancer can be a hardware load balancer. This load balancer can be a software load balancer, or cloud managed load balancer, based on where you are trying to set up. So we already have a dedicated video in our YouTube channel, rushitechnologies.com. If you go here, there is a link also for this YouTube, right? So here you can see there is a videos on this what is reverse proxy. Here first, load balancer versus reverse proxy, why they are used, why the different types. Again, if required, you can use the Nginx as a software based load balancer, and we can set up Nginx, and we already have a practical video on that Nginx as a reverse proxy to applications deployed in a Tomcat in virtualized deployment. And again, we discussed about DNS also, domain name. We discussed about this SSL TLS also. There is a 4 videos here. I hope you guys already went through. Now let's say here, this is the load balancer. In this, this can be a software load balancer. This can be a cloud load balancer like ELB in AWS, or if you are using Azure Cloud, Azure load balancers. Like this, we are going to distribute the traffic to these application instances. If required, this application can internally talk to some kind of a database, or maybe this internally this application is depends on some other application or third party application, or this application might be internally talking to some database. Let's say there is a database that can be self managed database, that can be a self managed database, or that can be a fully managed database like RDS in case of a relational, self managed or a fully managed. There is a database system, database software in order to store the data, like a database you will be having. Maybe let's imagine, again you are having a database. This application will internally talk to the database. Let's imagine this is our DB server, where you have configured a database. Application will talk to the database. Let's say this is your database process. Again, this can be a fully managed database, or it can be a self-managed database. That doesn't matter. This application will internally talk to these databases. So we discussed about databases also, and we discussed about self-managed database and fully managed database in RDS, in AWS like RDS. This is where the data will store. If required, this application also will talk to some other applications, dependent application. Even though it is a microservice or monolithic, in case of monolithic, everything is there in a single code base. All the modules or all the features are in a single code base. Everything is in a single code base. all the modules or all the features of our application is in a single code base. In case of monolithic architecture, we have some drawbacks and we have some challenges with this monolithic architecture. That is where people started microservices architecture. So that is also very, very important as a DevOps engineer. So we already uploaded one video here in our YouTube channel, right? Monolithic versus microservices. So this is also very, very important. I hope you guys went through this also, what is monolithic, what is microservices, but understand the concepts, whether your application is developed and deployed in a monolithic architecture or microservices architecture in a virtualized deployment, whether it is developed in a monolithic or microservices in a containerized deployment. Also, what is virtualized deployment, what is containerized deployment, also we discussed here, right? So here, now the end to end overall we are trying to overall I am trying to explain how all the things will work, coming to the infrastructure standpoint, coming to the application development standpoint, coming to the build continuous integration standpoint, deployment standpoint, and infrastructure management, configuration management, and again monitoring and alerting and logs also we need to collect now. So let's say this is developed and deployed in a virtualized deployment, virtual machines, and again everything is a single package, monolithic, right? So if you are not aware about what is microservices, what is monolithic and microservices, understand this video. There is a detailed video where I have explained pros and cons of monolithic and pros and cons of microservices. And if you don't know what is virtualized deployment, containerized deployment, if you don't know, you can go through this. But without having a knowledge about Docker, Kubernetes, you can't build and deploy your containers, and you can't orchestrate also. But as part of our regular sessions, we already discussed in a detailed way what is containers, what is container orchestration. So almost for more than 2.5 months, we discussed about this container orchestration tools like a Docker, Kubernetes in a detailed way. But now let's say this is a virtualized deployment. This is a virtualized deployment or virtual machines where you have deployed your application. Now let's say end customers, think of an end customers, end users, think of an end customers, end users. So these end users will start accessing the application. So using via this load balancer, request will come. Via this load balancer, request will come. The load will be distributed again. The load will be distributed again. They will not use IP addresses. They will not use IP addresses and port numbers. There is a concept called DNS. So what is domain name? What is DNS resolution, DNS resolver? All these things we already discussed. So there is a domain name. Let's imagine I have this application. Let's imagine Rushi Technologies application, right? So this is like a domain name. Just to give an example, www.rushi technologies. This is my domain name, right? So actually, this is one application, right? Users like you, me, like users means like for Rushi Technologies, students is the users, end users. The customers for my business, the customers for my application or my business is the students who wanted to learn the DevOps and cloud, right? Similarly, Flipkart. Flipkart is also an application. So it is an e-commerce application. It is an e-commerce application. So whoever wanted to purchase some kind of a products, right? E-commerce platform. So you and me as a end user, you are going to access Flipkart, you are going to search the products, you are going to whatever product you would like, you will add to the cart, you will fill your address details, you will fill your payment details, you are going to make the payments, you are going to track the orders like that. Imagine this is application. Imagine this is application like Rushi Technologies or Flipkart or Facebook or Twitter, whatever. Even YouTube also one application, right? Now let's say that application is running somewhere like this, and people are accessing via that load balancer, and there is a domain name. We discussed about DNS resolution, DNS resolver, all these things. Now try to understand as a end-to-end process now, from SDLC, software development lifecycle, starting from design, development, deploying in a lower environment and testing, and if everything looks good, promoting to the higher environment like production. Imagine this is production where you have deployed and end users are accessing. Now let's imagine if there are so many servers, there are so much requests coming. This server is running out of CPU. This server is running out of CPU or memory. This server is running out of some memory, storage. So before that servers and before that servers or before that applications are going to be impacted, you need to proactively start working on the issues. So you have to monitor. You have to monitor. So that infrastructure monitoring, what is happening inside the servers. This server has how much CPU utilization, how much memory utilization, how much storage is used, and the network statistics you need. Not only that, infrastructure level, maybe application, maybe application. If required, you can monitor the load traffic also via load balancer. How many requests is coming, right? You need a metrics per day. How many requests is coming per, in what time more requests are coming, and again how many requests is a success with the 200 response, 400 response, like that. You need that type of metrics. That is where you can use monitoring tools. That is where you can use monitoring tools like infrastructure monitoring or a server monitoring tools and application monitoring tools like a Prometheus for alerting. You can use Prometheus and alert rules and generate the alerts, and you can send. So you can have that agents. You can have that agents like a Prometheus agents in case we need a node exporter in order to monitor the nodes, the hardware node exporter, whether it's a virtualized deployment, whether it's a containerized deployment, that doesn't matter here. Instead of manually monitoring 24 bar 7, you need to monitor these applications or these servers. Instead of manually monitoring 24 bar 7, it is very difficult to manually monitor what is happening in this server, what is happening in this server. Is this server has enough CPU, enough memory? Is this database has working fine? Is the database is down? Is the database process is running or not? Like that, instead of manually monitoring all these things, this is where you can use tools like continuous monitoring and alerting tools like Prometheus or maybe Datadog or New Relic, Nagios. Like that, there are so many monitoring tools, right? So we already discussed as part of the previous sessions what is monitoring, what is server monitoring, why do we need to monitor. With respect to server monitoring, what is Prometheus and what is alert managers and Grafana, we already discussed in the previous sessions, right? Now let's say you can set up even though it is a virtualized deployment also, you can set up monitoring. Let's imagine this is your Prometheus somewhere as a virtualized deployment or a containerized deployment. You are running Prometheus in some server, maybe direct in a server or maybe as a container. Maybe this is also one software. So maybe directly in some server you can set up a Prometheus monitoring tool. So this monitoring tool will try to collect the metrics from various sources. Let's say node metrics, system metrics. Here, this is going to need some kind of a agents. We discussed about what is node exporter. So we need some kind of a exporter or an agent. So what that exporter will collect the node related metrics from that node. That is also going to be deployed here. That is your exporter or agent, monitoring agent. So this will contact this node exporter. It is going to collect the metrics. It is going to collect the metrics from all these places, right? So this Prometheus, we already discussed as part of our regular sessions here. What is Prometheus .yaml file? How Prometheus knows which targets it has to contact and how frequently it has to collect the metrics. We have defined in a Prometheus configuration file, Prometheus setting file. So then like this, it is going to collect the node related metrics. Similarly, if you wanted to collect the metrics about load balancing, suppose that can be a software load balancer like Nginx or HA proxy. You can have that agent, that node, that agent. For that one, different agent will be there. So from this load balancer also it can collect the metrics, so that how many request is coming and how many 500 requests, 400 requests, because this is going to track, this load balancer is going to track all the requests coming to the clients, and again response going from this servers also it is going to track. So how many requests came and what response status, 200 or 500 or 404 also, like that it will track here. So if required, Prometheus can collect this load balancer metrics also, not only server metrics. Even though this is running in some server, that server metrics as well as load balancing metrics also via that exporters or agent. So this is collecting all these things. Here you can create you can create a rules like alert rules if required. Then alert rules means based on the collected metrics, you can create alert rules. If any server is down, send alert. If any system is having more than 85% of the CPU utilization for 5 minutes, send the alert. If any system is having a 90% memory utilization for 10 minutes, send the alert, like that. So that alerts is like a notification. So we discussed about something called alert manager. We discussed about something called alert manager. So that alert manager also you can set up in the same system in case of virtualized deployment. In case if it is a containerized deployment, you can set up this Prometheus also as a container in your cluster, or this alert manager also as a container in your cluster in case of Docker Swarm. In case of Kubernetes, you are using as a container orchestration, then you can set up this Prometheus and alert managers, these exporters also as a pods in your Kubernetes clusters and the nodes like that. So this alert manager will have a settings, alert manager data settings file. Here you are going to have a receivers. Here you are going to have a receivers like email receiver or Slack receiver, like that. So that receivers are nothing but to whom it has to send the notification. So any issues happening in your servers or applications, then this is going to collect the metrics, and based on the collected metrics, you can create a rules. This alert manager will send the notification. It will send the notification to the application team or support team or infrastructure team. It is going to send the notifications. So this internal team, this application team or a support team, that can be application team or a support team or whatever, application team or support team or infrastructure team who is managing the infrastructure. So whoever for whatever stakeholders who wanted to send the notification, we can configure here, the notifications will go. So this is how continuous monitoring will be implemented, monitoring our infrastructure and infrastructure metrics and application metrics, like that. So based on any issues reported, these guys can fix that issues, or before that servers are going to be impacted, before that applications are going to be impacted, before this end users is going to impact, right? Before our business is going to impact, we can proactively take the actions on this application, in this infrastructure issues, or if the servers are having very high CPU utilization. So you can additionally add some servers. In case even you are using a traditional data center also, manually also you can set up. If there is a more load coming and you can see it is not sufficient, you can manually scale this. Otherwise, if you are using cloud like AWS, you no need to manually scale also. You can use something called auto scaling groups that we have discussed. But monitoring is very, very important still, right? What is happening in your servers applications, that is very, very important. And based on the metrics, you can create alerts, and based on the alerts, these guys can take some action. Now this is how we can do in a virtualized deployment. But let's imagine, whether it's a virtualized deployment, whether it's with a monolithic architecture, let's imagine this is okay. But let's imagine end users are accessing the application, request is going, and in this application somewhere that issue is failed. Let's imagine Facebook application, just to give an example. So some customer logged in and he is searching some product, and he is trying to add the product. He is trying to add the product, add to the cart, and he is trying to place order. But some it is failed somewhere here. It is failed somewhere here. Imagine there is a issue. So imagine there is a issue. So from where request came, and with what input it came, right? And where it is failed, we need that application team that need that kind of a messages, that logs. So that logging is very, very important. That logging is very, very important for troubleshooting the application issues. So logging is very, very important. As I already said, logging is very, very important. Suppose you are developing an application and deploying application, logging is critical in application development. We often add the log statements. The application team will add the log statements to the code. This application team will add the log statements to the code, that code for future reference, especially in troubleshooting issues. In small application with lower traffic, checking the logs is straightforward. Let's imagine small application in monolithic, again you have deployed, checking the logs is easy. Let's imagine maybe you can go to this, maybe there are multiple servers, request is going here, and in case of small application, or maybe in case of application developed in monolithic architecture, everything in that application code, it will generate the logs, that logs will be stored somewhere here. So what that application team can do, maybe if they don't have access to that server, as a DevOps engineer, maybe you can give the log file, this log file. Maybe if the request come to this server, that guy can check the log file in this system, like that. But imagine there is so many servers, your application is very big, and even though you developed in a monolithic architecture and virtualized deployment, let's imagine you have so many servers, and again we don't know, right, to which server request went, again which server request went, again whether that's a request went to this server or this server, you need to track, and you can go and check the logs here, like that. It is very difficult. It is very difficult. Even in a monolithic architecture with more servers in a distributed environment, your application is distributed to multiple systems, maybe in a multiple systems, again multiple containers again. So it is very difficult to go to each and every system and check the logs. System logs also you may need to check sometime, application logs also you can check sometime, system logs, OS related logs, application logs, whatever application you have developed, that application logs here you need to check. So this becomes very difficult in a distributed environment where your applications are being distributed into multiple systems, multiple replicas basically. So it is very difficult for checking the logs here everywhere. But understand, in case of physical deployment, I mean, say instead of virtualized deployment like this, imagine this is going to be deployed as a container, and you can have a multiple containers. Again, imagine if it is a microservice architecture. In case of microservice architecture, it is distributed. Login is separate module, registration separate module, separate deployment. Like internally, one microservice is going to communicate with other microservices. Internally, one microservice is going to communicate with other microservices. Let's say I am talking about this one, right? Microservice, microservices, microservices architecture. If you see, there is so much microservices internally one microservice is going to communicate with other microservice. Internally one microservice is going to communicate with other microservice, like that. Just to give an example, let's say here, imagine, just to give an example, here this is one microservice. Just to give an example, e-commerce only, right? Order management, tracking the orders, right? Can login separate module, user separate module. Internally this will talk to this one, this will talk to this one, this will talk to this one, and again this is deployed in a virtualized deployment or a containerized deployment, that doesn't matter. Suppose it is deployed in a virtualized deployment or a containerized deployment, that doesn't matter. Internally it is going to talk to this is going to talk to this is going to talk to this, and again this is deployed in some server, this is deployed in some server, this is deployed in some server, multiple replicas. Again, distributed environment I'm talking about, distributed architecture, right? Distributed architecture. So in that case, checking the debugging that application where exactly it is failed, it is very difficult. It is very difficult because we don't know where exactly it is deployed, where exactly it is failed. You need to go to each and every system. In case of virtualized deployment, you can check the logs, you have to check the logs of each and every service where it is failed, like that. It is going to be a distributed environment. Just to give an example, distributed environment, right? This is running somewhere, this is running somewhere, internally it is talking to this one. So as a development team, it is very difficult for them to trace the logs. So this is very difficult in tracing the logs, like that. So in that case, whether it's a virtualized deployment, even it is a containerized deployment in microservice architecture, or maybe virtualized deployment in a microservices architecture, or a containerized deployment in a microservices architecture, it is very difficult to trace, check the logs, because so many systems, so many containers, so many services you need to go through. So here in this monolithic and microservices. I have explained that also. What are the challenges with microservices? And again, using tools like this log aggregation and log monitoring tools, how we can collect the logs from various places. We can collect the logs and we can index that logs and we can store that logs in a central place, so that it will be easy for application teams to query the logs, search the logs. That is where I'm trying to come now, right? So here, in case of monolithic or microservices going on each and every system, suppose in case of containers, going and checking into each and every system, each and every container using Docker logs. In case of Kubernetes cluster, your application is deployed as a container. Your application is deployed as a container, and in each and every pod there is a containers, and using kubectl logs command, checking the logs is very difficult. So that is where we are going to use something called log aggregation and log monitoring tools. That is where we are going to use log aggregation or log monitoring tools. We have a tools like Elasticsearch. We have a tools like Elasticsearch, Logstash, Kibana. We have tools like Elasticsearch, Filebeat Kibana. You have a tools like Elasticsearch, Fluent Bit or a Fluent D Kibana, like that. So we can use that Elasticsearch or a Splunk. That is also one software, like a monitoring software. So you can set up Elasticsearch again, whether it's a virtualized deployment or a containerized deployment, whether it's a virtualized deployment or a containerized deployment. So you can deploy Elasticsearch in some system. Maybe let's imagine this is again virtualized deployment, or maybe if you are using a containerized deployments like a Docker or Kubernetes, like that, you can run that Elasticsearch components also, as a containers or virtualized also. Let's imagine you can set up Elasticsearch. This is one software. We will discuss about what is Elasticsearch in a detailed way, but let's try to understand. So this Elasticsearch is going to collect the logs. It is going to collect the logs from various sources. That logs can be your system logs, your application logs, your container logs, like that. But again, this Elasticsearch also need some kind of a agents who can send the logs, who can push the logs, who can send the logs or who can push the logs. Here there is something called Logstash, or maybe if required, instead of Logstash, you can use something called Fluent D or a Fluent Bit. Otherwise, you can use something called Filebeat. They are like a log senders. They are going to send the logs. They are going to send the logs. So that is like a agent. The way we have a monitoring agent, you are going to have that log agents. These applications are as systems will generate the logs. These applications are as systems will generate the logs. Maybe you are running your applications as a container. That container also will generate the logs. That application running in a container also will generate the logs, right? So here you can deploy that log agent. This log agent can be this log agent can be Logstash. This log agent can be Filebeat or a Fluent D, or it can be Fluent Bit, like that. Any one, or you can use a combination also, different. Then you can set up this log agents in whatever systems or whatever clusters or whatever places. So this log agents will collect the logs from various sources. So when you are deploying this log agent also, you can tell. When you are deploying this log agent also, you can tell. So from which place it has to collect the logs. Let's imagine this application is storing the logs in some log file. You can say send the logs from logs are stored in that log file path. Let's say this OS is storing the logs in somewhere system messages. So here you can tell this agent. You can tell the agent in this system from which location it has to collect the logs, system logs, application logs, container logs, like that. You can collect also everything. And this log agents will collect the logs. And this tool like Elasticsearch, these guys will send the logs. These guys will send those whatever logs collected from that system, from that sources in the system. So again, you can set here settings also, you can define from which place in the system it has to collect and send the logs, like that. All the logs will be collected and stored and indexed here. Centralized log management now. Centralized log management. Now, if you are collecting the logs and aggregating the logs, log aggregation and log monitoring. So log aggregation, these log agents is going to collect the logs and they are sending the logs and aggregating. We are going to aggregate the logs here and index the logs and store the logs here. So this Elasticsearch will collect the logs from all these agents wherever your applications are deployed in a distributed environment, also in a distributed environment, whether it's a virtualized deployment, whether it's a containerized deployment, whether it's a monolithic microservices, that doesn't matter here. So you can all collect the logs, index the logs, all these things with the help of these agents. You can collect the logs. This log agent can be a Logstash. This log agent can be a Filebeat. There is a something called FluentD or a FluentBit, like that. Anyone you can use, or combination of multiple also you can use. And here it is going to store and index the logs, right? It is going to store all those logs and it is going to index that logs. This is going to internally store all the logs collected by this. Prometheus is also collecting different. It is not collecting the logs. Prometheus is collecting the metrics like CPU metric, memory metric, storage metric, application metrics, like that. But this is going to collect the logs and store the logs. This is log. This no, it is going to collect the logs and store the logs, right? Like our application logs, system logs, like that. Then Elasticsearch also don't have a nice visualization to query the logs. It is storing the logs, indexing the logs. But if required, you can use a tool like there is something called Kibana, ELK, EFK, Elasticsearch, Logstash Kibana, or Elasticsearch, FluentD, or a Filebeat, or a FluentBit, like that. Then this Kibana can search the logs from here. It can take the logs. It can contact Elasticsearch. Here, the development team, DevOps team, development team, development team, or a DevOps team, they no need to go to each and every place, system, checking the system logs, application or a container logs, whatever it could be. So you can just use this Kibana. So here you can just visualize, just you can search the logs, you can visualize your logs, you can query the logs, and you can see all the logs in the same place, like this. Prometheus is for metrics, and again for Prometheus visualization you are going to use Grafana. Metrics visualization, Grafana, right? So this we already discussed in the regular sessions. Right? Already we have this Grafana. So Grafana will contact this Prometheus, and where we can visualize, like this. This is for logs. Understand whether you are deploying your applications like this virtualized deployment in a monolithic architecture, or virtualized deployment in a microservice architecture, each and every service deployed separately, like that. Otherwise, if you are using Kubernetes, or a Docker Swarm also, the concept is same. But here I am not drawing the diagram. Maybe in Kubernetes, here you will have a cluster. Right? In this cluster you have a servers. You are not going to directly deploy like this. You are going to have a container images. So you are going to build a container images, and you are going to deploy that containers. In Kubernetes, you have to deploy the containers. You have to create a deployment services, ingress rules. We already discussed about all those things on our regular sessions. I don't want to get into that, but I hope this is going to make everything clear. What is this DevOps? What do you mean by continuous integrations, continuous delivery or deployments that we have already implemented using Jenkins into a virtualized deployment? If required, we can do that in a containerized deployments in Docker Swarm clusters, Kubernetes clusters also. Instead of we manually create the pods, deployment services, config maps, volumes, you can create them via CI/CD using manifest files or Helm charts also, that we can do. And again, monitoring and log monitoring and log aggregation. So with this introduction, let me get into what is Elasticsearch, what is Logstash, what is Filebeat or FluentD, or what is Kibana. So here, as I already said, logging is very critical. Logging is very critical in application development. We often add the log statements to our code, like this. Application team will add these type of log statements, exceptions, errors. If something is failed, this type of log statements will be added, so that they can understand, okay, any request goes to this, okay, request went to this, from this, okay, this input went, this output returned, like that. We can see the logs. So you can trace where exactly the request is failed, with what input it is failed also. You can trace where exactly it is failed also, in which class, which service, which class it is failed also, you can trace. But without this centralized log monitoring and log aggregation, it is very difficult to go to each and every system, each and every system and each and every container, or like that containerized deployment, like Docker logs, kubectl logs, like that. It is very difficult. So that is where this is coming here. So first, logging is very, very important in application development. They are going to add log statements to the code, especially troubleshooting issues. In smaller applications with lower traffic, checking the logs is straightforward, even if it is a virtualized deployment, or maybe in case of containerized deployment in Docker Swarm or Kubernetes, maybe Docker logs or Kubernetes logs, like that. But as applications grow, as applications grow, especially in a microservice architecture spanning multiple instances, multiple servers, and again that is a cluster, and again distributing that microservices into a multiple containers, and again each container is deployed in a different node in the cluster. So it is very difficult in a distributed architecture. So spanning into a multiple instances and managing the logs become challenging. So running kubectl logs or a Docker logs or number of pods and multiple services is not practically possible. So to address this challenge, we need efficient log management. So to address this challenge, we need an efficient log management system to quickly locate the information we need when any issue occurs. Right? So that is where we can use this monitoring, log monitoring. So monitoring and alerting, log aggregation, not application monitoring. I am talking about log aggregation, log monitoring. So whenever any, understand, suppose there is some errors or exceptions occurred in your code, in the log messages, if you see any keyword like error, exception, understand. So this can again send the alerts also, guys. Suppose your application somewhere it has failed, it has generated one log message with error or exception. This Elasticsearch is collecting that, and Kibana can query that. So here in you can create one kind of an alert also. Anytime in the log messages, if you see some keyword like error, exception, immediately it can send. Before that issue is reported also, before that issue is reported also, suppose that this log aggregation tools are collecting the logs, and in that log messages you see some keyword like error, exception, like that. Just to give an example, the message, right? Exception occurred, error occurred, like that. If you see, then if required, you can send a notifications also, like based on the messages, log messages or log statements also you can send. So before your users are going to report, or before your users are going to report that issues, you can get the alerts, and you can check the logs in which request it is failed, why exception have happened, like that also you can do. That is what I'm talking about here. Monitoring and alerting log statements also essential for smooth functioning of production grade Kubernetes clusters and applications in the Kubernetes clusters or virtualized deployments also same. Application and system logs, application logs as well as your system logs also will help us to understand what is happening inside your application, also application as well as what is happening inside your system. That logs, these logs are useful for debugging problems and debugging issues in application. In case Kubernetes logs also, that Kubernetes logs, your API server logs, etcd logs also you can collect, and you can understand what is happening in the cluster activity logs. So in a microservice architecture, a single business operation might trigger multiple microservice calls. So this can be pretty challenging to debug. However, it can be easier when all the logs, it can be easier when the logs of all microservices are centralized. So this things becomes easy with centralized log management. So things, however, it can become easier when the logs of all your applications are microservices running in a virtualized deployment or running in a containerized deployment. If they are centralized, each log event contains the details that will allow to trace the interaction between the applications where it is failed, like that. So we can use this Elasticsearch. We can use this Elasticsearch to collect, process, store, index, visualize logs. Logs of not only microservices, that just I am giving here. Logs of your application, that application is deployed in a monolithic architecture or a microservices architecture, that doesn't matter. But nowadays, if you take any application or any business, if you take any application or any business, right? So you can, nowadays everyone is developing in a microservice architecture. So here there is a stack, elastic stack. Again, it's a group of softwares. It is not a single software. So elastic stack is like a group of open source softwares. Elastic Stack is, it is like a group of open source applications or a softwares from Elastic, designed to take the data, from any source and in any format, then search, analyze, and visualize the data in a real time. So this is there is something called ELK, Elastic Search Logstash Kibana. So ELK and EFK. Either you can go with the ELK or EFK, like that. Again, this ELK full form is Elasticsearch, Logstash. That L stands for Logstash, K stands for Kibana. Here in EFK, there are so many, right? This ELK, EFK. Again, here same Elasticsearch, Logstash. Instead of Logstash here, it can be Filebeat. There is something called beats, file beat, metric beat, network beats, like that. That beats will collect the data. And it will send the data to the Elasticsearch. Right? There is a file beat. Otherwise, instead of file beat, again you can use something called fluentd. Otherwise, this F, there are so many. You can use file beat, or instead of file beat, you can use something called fluent bit. Or instead of fluent bit, again, instead of fluent bit, if required, you can use something called fluentd, Logstash, file bit. Or instead of file bit, again, this file, it can be fluent bit or it can be fluentd, like that. Basically, these are like agents, collecting the logs, formatting the logs, and sending that logs to the Elasticsearch will store that logs, index that logs, aggregate or index that logs, store that logs. So Kibana can contact Elasticsearch and get the logs. But here, instead of a file bit, you can use a fluent bit or fluentd also. But the concept is same. But instead of file bit, you are going to deploy fluent bit or a fluentd. Again, there is a small differences between these two, fluent bit, fluentd, Logstash also, that you can easily understand, right? But Logstash is going to consume so much CPU and so much memory compared to the this fluent bit, file bit. But Logstash is going to have so many advanced log parsing. You can, before that, logs are being sent to the Elasticsearch, it can format the logs, it can parse the logs, it can prepare the logs also in a required format, like that. Lot of parsing features and a lot of plugins are supported in Logstash compared to this fluent bit, fluentd, like that. So based on your requirement, you can, Elasticsearch and Kibana is same. Based on your requirement, you can replace a file bit with Logstash also. If required, you can replace this, instead of a file bit, you can replace this file bit with maybe Logstash, or maybe you can replace with fluent bit also, like that. So anyone is fine, but one I will try to explain, that is file bit. If required, again, file bit can be internally, instead of file bit directly sending to the Elasticsearch, this file bit can again internally send to the Logstash also, if required. That Logstash can process that log, parsing that logs, and in prepare in some format that is expected by you. Like this, there are so many customizations also you can do, that is based on your needs, right? Now, let's say it is like a group. Elastic Stack is like a group of open source applications or a softwares from Elastic, designed to take the data from any source and in any format, then parsing that log messages, sending that logs, visualize the logs, like that. So there is something called ELK, Elasticsearch Logstash Kibana, right? So there is the link also I have kept here, ELK. This is the official website, Elastic. So ELK, Elasticsearch Kibana, but this integration these integrations can be done with anything like Logstash Kibana, Logstash, or maybe Fluent bit file like that. So here, what is Elasticsearch, what is Kibana, they're trying to explain here, like all these things. Again, you can deploy this Elasticsearch also in a Elasticsearch also. You can download and install in a virtualized deployments also if required. You can download and install in a virtualized deployment also. You can install like a Linux server, right? Or on-premise or any server like that manually. Or if required, you can do this as a containerized deployments also like that. But let me tell you, Elasticsearch, Logstash, Kibana, in which the letters in the name stood for Elasticsearch, Logstash, Kibana. Fourth one is beats. There is something called beats. Right? File beat, metric beats like that also you can use. So instead of Logstash collecting, instead of beats can collect the send the logs or metrics also if required to the Elasticsearch, or maybe directly to the Elasticsearch via Logstash. Again, it can send like that. But for now, let me tell you, Elasticsearch is a real-time distributed storage and JSON-based search analytics engine. Engine designed for horizontal scalability, minimum reliability. So it is used for many purpose. But one context where it is more widely used, it is used for many purpose, not only for log aggregation, right? It is used for many purpose, but more widely used is streaming. It is streaming the logs, streaming the structured data such as logs and decoded network packets like that also. This is Elasticsearch. So Elasticsearch is one software, right? It is widely used for indexing and streaming the logs from various sources and indexing the logs and storing the logs here. So the Kibana is again one more software. So Kibana you can think as a visualization designed to work with Elasticsearch only. This Kibana is a visualization software designed to work with Elasticsearch. Kibana can be used to search and view and interact with the data stored in Elasticsearch. So this Kibana allowing advanced data analytics and visualizing the data in a variety of charts, tables, maps, like that also we can do Kibana visualization. And there is something called a Logstash. You can take the logs from Logstash, and basically Logstash can send the logs to the Elasticsearch. Otherwise, there is something called beats, file beat like that. Otherwise, instead of file beat, again you can go and use a fluentity. That is different. So these beats are often data shippers. Like a beats are often data shippers that can be installed as an agents, on the servers, and or maybe containers to send the data directly to the Elasticsearch. It can send the data directly to the Elasticsearch. Otherwise, you can bring again Logstash also. Again, let's say this is your file bit that is deployed as an agent in each and every place where you need to collect the logs. Again, this can directly send the logs to the Elasticsearch. But if you wanted to parse that logs and you wanted to customize the logs before sending to the Elasticsearch, you can bring Logstash also again here. So when you are deploying this file bit, you can tell whether this file bit has to send the logs to the Elasticsearch directly. Otherwise, whether this file bit has to send the logs to the Logstash, then Logstash can send the logs to the again Elasticsearch like that. Also, you can configure. So this Logstash has some advanced parsing, advanced more plugins is supported. If required, you can use this. But nowadays, in containerized deployment, containerized applications, Kubernetes clusters, maybe you may not don't use Logstash in between. If required, this file bits or maybe fluentity instead of file bit, maybe fluentity. That fluentity or a fluent bits also can directly send the logs. But if required, again you can bring Logstash also in between. Either you can directly go with Logstash, but Logstash, if you are deploying in each and every agent, if you are deploying Logstash as an agent in each and every system, that Logstash is heavyweight. It will consume so much CPU, so much memory in that systems where you are installing that Logstash as an agent. But what you can do, you can configure maybe Filebeat, you can configure maybe Filebeat, or maybe FluentBit, Filebeat or a FluentBit, or maybe FluentD as an agent. It can directly send the logs to the Elasticsearch without Logstash also. If required, the Filebeat or a FluentD will consume less CPU, less memory, that you can deploy in each and every system where you need to collect the logs. Then this will internally send to some Logstash again. That Logstash you no need to deploy in each and every system again. Maybe as a one replica somewhere you can deploy. Then the file bits are a fluent, this fluent bits can internally take the logs from that, and it will send the logs to the Logstash, and Logstash can process and enrich that logs, and again it can send to the Elasticsearch. It is optional, it is optional, you don't need to bring Logstash in between. If either you can directly send the logs from these agents, like these systems using Filebeat, or maybe you can use Filebeat, or maybe you can use a FluentD or a FluentBit. Directly you can send to the Elasticsearch. But you wanted to do some kind of a parsing the logs again. You wanted to change the way the logs has to be displayed here. Again, you can bring in between. Again, you can bring in between between this Filebeat or a FluentD. Again, you can bring Logstash, but Logstash no need to be deployed as an agent in every system. You can deploy Filebeat or a FluentD, and this will send to the Logstash. This Logstash can internally send to the Elasticsearch, but here some kind of a advanced parsing transformations will happen. Whatever log messages your applications are generating also, it will send here, but there is some kind of a transformation will happen, some kind of a makeup according to your needs, some kind of a makeup you can do for that, basically transformation. You can generate some additional information with that log messages, and you can send also if required. But if required, you can directly go with Logstash. But a problem with directly going with Logstash is heavyweight. Suppose you are deploying Logstash in each and every system, it is going to take more CPU, more memory. So you can do with, based on your needs, based on your requirements, based on where you are running. So anything you can do. For now, I am directly going with Filebeat. There is no middleman called Logstash, and Filebeat. Filebeat will send the logs to the Elasticsearch. Kibana can query the logs from Elasticsearch like that also. All these customizations can be done using settings. So this Filebeat also will have some setting file, right? So in that settings file, you can tell whether that Filebeat has to send the logs to the Logstash or maybe directly to the Elasticsearch. Similarly, when you are configuring FluentBit or a FluentD also, you can do settings, input and output like that. When you are configuring this Filebeats as an agent, or FluentBits as an agent, input means from where it has to take the logs, from which path in the system it has to take the logs. Output means to where it has to send the logs, whether it has to send that data to the Elasticsearch directly, whether it has to send the data to the Logstash, then Logstash can internally send the data to the Elasticsearch like that. You can configure using settings. Everything is customized and configuration you can do. But for now, instead of a Logstash, now we are going to use a Filebeat. So Logstash is a powerful tool that is going to integrate with variety of deployments. It is going to offer so many plugins. It will help you to parse and enrich, parse the logs and enrich and transform. Transformation means some, let's say, some other information can be injected into that log statements or a log message. Even though your application is generating this, maybe here you can you know add some other information also to that log statement like that. That is what a transformation, right? It can do that transformation also if required. So now, what now I will do? Filebeat I will use. Filebeat I will use to collect the data from the log files, and you can send it to the Logstash, and the Logstash can enhance that data and again send to the Elasticsearch. Otherwise, we can directly do this also. Logstash Filebeat, or file, this can be Filebeat, this can be FluentD or other also fine. Now this Filebeat can collect the logs, and I can directly send to the Elasticsearch also. Now I am not bringing Logstash in between. I can do directly like this also. Then Elasticsearch will store that logs and index that data. Then Kibana will display. So this is typically ELK architecture. This is typically ELK architecture. Your applications. This is your servers. your applications will generate the logs. This Logstash can collect the logs from all these by deploying this Logstash itself as an agent. This Logstash will send the logs to the Elasticsearch. We can visualize the logs in Kibana. Otherwise, you can bring for data collection, for collecting that logs, that data, you can bring beats. You can configure that file beat as an agent. This file beat will be deployed as an agent in each and every system wherever you are deploying your application in a virtualized deployment. Suppose if it is a containerized deployment or a Kubernetes deployment, if it is a containerized deployment or a Kubernetes deployment, you can deploy that file beat in each and every node, as an agent. Then this is again optional. Data collection, it can directly send that data to the Elasticsearch, and via Kibana you can visualize. Otherwise, you can bring also, because when you are configuring this beats like a file beat, there is a settings file. Here you can say input. Input means this has to take the logs from which path, which location, like that. Then output means this has to send the logs to which one, whether it has to send the logs to directly Elasticsearch or it has to send the logs to the Logstash, like that. You can also do that. So for now, I am bypassing this Logstash in between. Directly, it will send the logs to the Elasticsearch, like that also. Here, basically, this is what the complete architecture. So Elasticsearch can take the data directly from beats like file beat, or maybe this Elasticsearch can take the data from Logstash. Internally, this can beats can send the logs to the Logstash, and it can take like that. Kibana is like a visualization. But instead of file beat, again there is something called fluentd. Fluentd. You can use that fluentd and other things also in this. Suppose if you don't know also, if you know the concepts, everything becomes easy. Suppose you can understand what is difference, what is ELK stack. So there is so much documentation also. Elastic ELK Stack is a collection of 3 open source software: Elasticsearch, Logstash, Kibana, used for searching, analyzing, visualizing large amount of data, primarily logs. Primarily logs. This Elasticsearch is the search and analytics engine. Logstash will handle the data collection. The Logstash will handle the data collection. It will collect the data, that logs data, and it will process. And Kibana provides the user interface to visualize this data. So Elasticsearch, Logstash, Kibana. So how it works? Logstash. Logstash Logstash is collect the data from applications, servers, and other sources. Now, if required, you can use a beats as an agent instead of Logstash, right? Logstash. Then processing. That Logstash will process the data. Filtering, transformation also will happen. Suppose even though the you are collecting, there is so much logs generated, but you don't want to send all the logs to the Elasticsearch. You wanted to filter some logs. That logs, like you wanted to filter junk, even though your application or maybe in your system some logs are getting generated, that you don't want to send that to the Elasticsearch. If required, you can do that filtering, transformation also in a Logstash. Then this is the processed data. The processed data will send to the Elasticsearch for storage. Kibana can be visualized. So centralized logging, aggregating logs from multiple systems into a single searchable location, and providing real-time insights to the what is happening in your application also, like that. So you can use this ELK or you can use EFK. So what is difference between ELK and EFK? Again, in this EFK, there are so many things. EFK, there are so many things. So two popular open source log management. Here, Elasticsearch Logstash Kibana, Elasticsearch Fluentd Kibana, or a Filebeat Kibana also, Filebeat. So this F stands for Fluentd or a Filebeat, Fluentd or a fluent bit. Otherwise, there is something called Filebeat. Filebeats. Filebeat. EFK. F stands for Filebeat also. You can use Filebeat also. That is also you can use. So this Filebeats. Filebeat. There is something called file beats. So you can use this file beat also. So Logstash versus Fluentd. Logstash is powerful, complex data pipelines, but resource intensive. More resources it will take. Fluentd is a lightweight. Fluentd is a lightweight and efficient. Right? Again, instead of fluentd, you can go for Filebeat also. So Filebeat is again separate, lightweight. Instead of fluentd or a FluentBit, again you can go with Filebeat also. This Filebeat is again separate and lightweight again. That is going to get the logs and forward that logs directly to the Elasticsearch also it can forward, or it can search forward to the Logstash. You no need to deploy that Logstash in each and every system. You, even though you wanted to do transformations, filtering, all those things also, instead of deploying in each and every system, maybe Filebeat you can deploy in each and every system from where you wanted to collect the logs. That logs can be sent to the Logstash. Logstash can do the transformation, filtering, and then send to the Elasticsearch. Otherwise, it can directly send to the Elasticsearch also, like this, right? So here you may use a ELK or you may use EFK. That F can be FluentBeat, Filebeat, or FluentD, like that. For now, I am just taking one, but the concept is same. The concept is same. Okay? So now let's say whether it's a virtualized deployment, whether it's a containerized deployment, whether it's a virtualized deployment, whether it's a containerized deployment, you can do this. Now, let's say we have a Kubernetes cluster. Anyhow, nowadays every application is developed and deployed in a Kubernetes only. Let's say we have a Kubernetes cluster. In that Kubernetes cluster, I have my applications deployed, and I have a monitoring also deployed, let's say, like Prometheus, Grafana, like that, for application monitoring, server monitoring. Now, similarly, we have this log aggregation, log monitoring. Similarly, we have this log aggregation, log monitoring tools, right? So we can deploy this to collect the logs. Maybe let's say you have a Kubernetes cluster with hundreds of nodes. Let's imagine you have a Kubernetes clusters with hundreds of servers, and each server has so many pods. Again, you are developing your application in a microservice architecture, and each microservice is deployed as a containers in your Kubernetes pods. And again, each microservice will have a multiple replicas, multiple pods. So we no need to go to each and every pod, cubes, ETL logs, like that. All these logs from all the systems, all the logs from all the containers or all the pods from all the systems can be collected and processed and sent to the central location, so that we can query and visualize the logs. So that is how the transformations will happen, and we are going to use. Now let me deploy this into my Kubernetes cluster. The prerequisite, it is not mandatory that you can only use with Kubernetes. As I already said, you can use in a virtualized deployments also. You can install in case of Docker, with the Docker Swarm also you can install. But if I have a Kubernetes, we can install in Kubernetes. Again, in order to deploy this, you may need to create a daemon sets. You may need to create a daemon set, that agent, that Filebeat agent, if you are using Filebeat, or if you are using FluentD, that FluentD has to be deployed as a daemon set. And again, this Elasticsearch can be deployed as a stateful set. Maybe you need Kibana, that Kibana also can be deployed as a stateful set or maybe deployment. And again, you need to create a deployment, so stateful sets or maybe daemon sets and services for them, and config maps and secrets for providing a configurations or a settings, like that. So you can create all these things. And again, this Elasticsearch also will store the logs. So we need a storage, we need a values, persistent values, we need a values, persistent values, right? Suppose without values, again, if you are deploying whatever logs collected by this Elasticsearch from that maybe Filebeat or FluentD, whatever you have used, if the parts are deleted and recreated, again your logs, whatever collected and stored by this Elasticsearch, no more. So you can use this for storing values, right? Persistent value. So make sure you have a Kubernetes cluster with the maybe storage class configured. I have a Kubernetes cluster, I have a EKS cluster with the storage class configured. We discussed about what is storage class, EBS provisioners, we already discussed. And again, I should have a Kubernetes cluster with at least some CPU and memory, because we are going to deploy this also into a cluster. But I have a EKS cluster with auto mode. There is a carpenter embedded there. There is a carpenter embedded there, right? So we don't need to worry, node provisioning, it is going to take care. But if you are using AWS for free tier, maybe you have a limitations on the number of CPUs you can use. Suppose if you try to deploy more, maybe free tier account will not allow you to create a more servers. That time maybe your pods may go to pending state, that nodes also will not be created. But anyhow, I have a free tier, but I have requested to have a more CPU. They approved the request. I can have more servers also. Now let's deploy. You can use Kubernetes manifest files also, guys. You can write a detailed manifest files like Elasticsearch, stateful set manifest, service manifest, required config maps also as a Kubernetes YAMLs for Elasticsearch, Filebeat, Kibana also. But if already there is a Helm charts, we can go and add the Helm repository, and you can deploy with our own values also. Instead of default values, you can configure our own values. The prerequisite for this program, right, what I am showing in a Kubernetes, but it is not mandatory that you have to use Kubernetes only. You can use in virtualized deployment, containerized deployment in Docker Swarm also. Now let's say I already have a Kubernetes cluster. Let me show that. Let me log in my AWS account. Let me log in. So let me log in to my AWS account. So I already have one EKS cluster. EKS cluster created in auto mode, but it is not mandatory that you can do only in EKS. So that can be a single node Kubernetes cluster. Even in your local laptop or a desktop, you have a mini kube cluster. There also you can set up. Otherwise, it can be a multi-node Kubernetes cluster, self-managed or bare metal. Suppose you have an on-premise data center. In your on-premise data center, you have a Kubernetes cluster that is self-managed. There also you can deploy. Otherwise, it can be a fully managed Kubernetes like EKS, AKS, GKE. That doesn't matter. If you know the concepts is important. So I believe concept is king, principle. So without understanding the concept, if you blindly do learn, if you blindly follow some instructor, some trainer, even me, if you are blindly following me, Balaji sir is doing step one, do this, step two, do this, step three, do this, follow these notes. So follow these notes. I don't encourage that step one, do this, step two, do this, step three, do this, like that. If you know, it is not going to work out. So understand the concept. That's why my trainings and my teaching will be more focused on concept oriented. Concepts oriented. First, I will try to make the concepts more clear. Then once you are clear about the concepts, then we will go for design or implementation. Right. So today I am implementing this way. Tomorrow you can go other way. Right. Maybe your requirement, maybe instead of file bit, you can go with fluentd. So you already know what is elasticsearch, what is this, then how you can integrate, like how you can replace also, everything you can easily know. So that's why. So don't blindly think only it can be used in EKS only, like that. That can be even self managed. I have an EKS cluster already created with auto mode, and I have a one system one system where I have configured my kubectl. I have configured my kubectl and kubeconfig file, and I have Helm also here. Helm because I wanted to deploy via Helm charts. So let me connect to this. Let me connect to this. Let me connect to this system where I have a kubectl installed. You can see kubectl get logs. Sorry, kubectl get nodes. So I have some nodes already, and I have some namespaces already, and we already have some applications also deployed. We already also have some applications also deployed in this namespace, and I have deployed ingress controller, and I have created ingress rules to access this application. This application is already deployed with the HPA. Everything is there. Now I have a storage class also configured in this cluster that is marked as a default storage class again. This we discussed as part of the regular sessions, right? What is the what in a detailed way. Now let's say we if required we can we already deployed Prometheus and Grafana also as part of the previous regular sessions. Now let's see now Elasticsearch Filebeat Kibana. So that is also available as a Helm chart. If I go to Artifact Hub, you can see Elasticsearch. This is the official organization Elastic repo Elastic like that. You can add this Helm repo. You can add this Helm repo. So you can add the Helm repo. So Helm repo you can add. You can see Helm repo add. You can repo name anything. We already discussed about Helm also, right? So here in the documentation also I have given same. You can add a Helm repo. Before that, let me create one namespace, like one namespace where I will deploy all that monitoring. I mean, it's a log aggregation, log monitoring related Kubernetes resources. kubectl create ns. I'm just creating a EFK Elasticsearch like this EFK ns something like this or EFK like that. It's up to you. Now there is a namespace created. In this namespace, I don't have anything as of now. In this namespace, we don't have anything as of now. Now let me add the Helm repository. Helm repo add anything, right? This is my repo name. In this repository, there are so many Helm charts. There are so many Helm charts. Suppose Helm search repo name if I give, we already discussed about Helm, guys. Okay? So Helm search repo name. Helm search repo name. Repo name is Elastic, let's say. So in this repo, there are so many Helm charts. You can see there is a Helm chart for Elasticsearch. There is a Helm chart for Kibana. There is a Helm chart for Filebeat, like that. Or there is a Helm chart for Logstash also. But instead of using Logstash, I will use a Filebeat for now. If required, you can use a Filebeat with Logstash also. Customizations can be done. Customization can be done based on your requirement again. So now, let's say first I will try to deploy one after the other. But if required, I can deploy with the default values. But if you wanted to customize also, you can customize, because with the default values, let me show this Helm show values. This we already discussed. So this is the values file. So here there is a values file for Elasticsearch, right? So if required, you can configure, modify the settings of this one. So if you see by default, it is requesting 100 millicore CPU, that is one CPU, and requesting 2 GB memory. But it is internally going to have a multiple replicas also. That is also there, default settings. So replicas, multiple replicas, 3 pods will be created. Three pods will be created for that Elasticsearch. 3 pods will be created for Elasticsearch. That Elasticsearch also running as a cluster. Elasticsearch also running as a cluster, like a primary and secondary like that. That is there in that settings. Again, so this is default files. For now, if I request with this default files, it is going to take so much CPU, so much memory. In real time, it is really required. It is required at least this much, minimum 2 GB, one CPU. But if I go with this, it will take a lot of CPU, but we don't have that much capacity. We are using free tier account. We are using free tier account. What you can do, you can request less CPU. Maybe for now, let me request only less CPU, 500 millicore request, and maybe just 1 GB MI limits. Okay, fine. So this is values file. What I will do, I will create my own values file, like a VI elastic search values.ml. Only I am changing this, nothing else. With this, I will deploy the Elasticsearch. You already know how to do this via in Helm sessions. We already discussed. So I will do Helm install with that values file. The file name can be anything. That file name I have created Elasticsearch. So in this namespace, I will do that EFK namespace. I am deploying that Helm chart with my own values. In that values file, I have only modified the resource request. So EFKNS, the namespace name is EFKNS. So now I have deployed Elasticsearch. Now Helm ls -n EFKNS. You can see there is a release created, this Helm status, this EFKNS. You can see it is getting created, but this went to pending because of no nodes. But this carpenter, this EKS with auto mode carpenter will create a nodes also. This parts will be scheduled. This Kubernetes concepts we already know, leave it. Now anyhow I will proceed further. Right, we have deployed Elasticsearch. Now if required you can deploy Kibana. If required we can deploy Kibana. So let's wait for some time. Let's wait for some time. Obviously this nodes will come, new nodes will come, because there is a carpenter. There is a carpenter. That carpenter will try to create a nodes. This is specific to EKS auto mode, right? So this is specific to EKS auto mode, but in other clusters you may have already nodes with so much CPU, so much memory. Also if you don't have, you can manually create the nodes, join the nodes like that. We already discussed all those things in a regular Kubernetes sessions. Let's wait just for a couple of minutes. This parts will be created. Later I will proceed. Later I will proceed. Right. Later I will proceed once these pods are running state. Anyhow it will come. It will just wait for a couple of minutes. Maybe we will wait for 2-3 minutes. We'll wait for 2-3 minutes. Maybe let's see if is this ready now running. But there will be health checks, right? Kubernetes liveness probes, readiness probes. After that it becomes ready. Anyhow the carpenter might have been added additional nodes that we already discussed. What is EKS auto mode, what is carpenter, like that you may see some additional nodes got created. But if you don't have a more if you are using AWS free tier account, right, maybe if you don't have a so much CPU, so much service quota, maybe you can request with the 300 millicore, maybe you can request with the maybe just 512 mi like that. But if you again request with less CPU, less memory, it may not work. But if you don't have, use this. But for production it is not recommended less CPU, less memory, because it is going to use some CPU. It needs some CPU for processing, indexing the logs, or parsing and enriching all those things also it is required. This is for Elasticsearch. So for now, okay. Now we have that Elasticsearch only deployed. But Elasticsearch only deployed, but someone should send the logs to this Elasticsearch. That is where this Logstash or that Filebeat or maybe FluentD or a Fluent bits will comes into the picture. So if you wanted to use a Filebeat, you can go and use Filebeat also. If you wanted to go and use FluentBit, you can use FluentBit. So it is easy. Deploy FluentD, FluentD or FluentBit, either anyone. Deploy FluentBit in Kubernetes for Elasticsearch using Helm. Instead of a Filebeat, you can use this also. So what you can do, you can add this, right? This is FluentBit values. In this fluent bit values, you are going to configure something like your Elasticsearch. So this is settings file, customization you can do, right? You can do these customizations and you can deploy also like this if you know. Otherwise, with the default also, it will do the same. With the defaults also, it will try to send to the Elasticsearch only. This fluent bit repository you can add and you can deploy with these values. But here you can give that Elasticsearch service name, Elasticsearch service port, like that. Elasticsearch service name, Elasticsearch service port, like that. Otherwise, it will use that defaults also. Defaults also there. Without adding, you can see default values also. It will be created. This is a values file. Using this config map will be created for fluent bit. Then it will use that for configurations, sending that like that. So you can use fluent bit or file bit or fluentd, whatever. For now, I am using file bit. So let me show that file bit is also one kind of a agent that will send the logs. So I will deploy this Kibana later. I will deploy this Kibana later. First, let me deploy that file bit. So that file bit is also part of this same Helm repository. So first, let me show the default values. Let me show the default values. Helm show values. I already added this Helm repository. So not this, not Kibana. I wanted to see the values of file bit. This is the Helm chart name, which is part of this repository. Now you can see this is the default values. Here already there is a default settings also. Already there is a default settings also here. File bit config, right? So output and the file bit input and output. So output means this file bit is going to collect the logs. To whom it has to send the logs? Already it is configured to send the logs to the Elasticsearch. So it is already configured to send to the Elasticsearch. It is internally using that Elasticsearch endpoint, that service name. And in Elasticsearch will have some username and password that is also taken like that. So the file bit is going to collect the logs. So this file bit is going to be deployed as a daemon set. By default, it will try to get the logs from this location. Suppose you have some logs in a different locations also. Suppose you have a logs in a different location. Suppose your term, just to give an example. Suppose just to give an example, you have a logs in a different location, like maybe in different path also you have. You can customize. Let's say you have some logs in this folder, some log files in this folder, something like this, something like this. So whatever files you have in this folder also will be collected by that file bit. This file bit is going to be deployed as an agent in each and every system as a container or maybe directly. So these logs, or maybe you have some other logs in separate system logs. Suppose you have some sys logs, all those logs also from these paths it will collect, send to Elasticsearch like that. Suppose if you don't want to send to Elasticsearch, you can configure here to send to the Logstash also. Then Logstash can internally send to the Elasticsearch. This type of customization can be done using values, and this is internally used as a config map created. So we already discussed what is config map, what is how to use config maps to pass the configurations also, and in our Kubernetes sessions, right? So now I am just deploying with the default also. If required, you can add like this also. In case of file bit, in case of fluentd, different. In case of fluentd, the same settings will be in a different format. Suppose if you want just to give an example, you can do all this customization also. You can deploy with custom. So let's say suppose you wanted to configure, let's say from this containers will generate the logs in these locations like that also you can send, and you can do lot of like inputs like this, or you can go with the defaults also. Already the container logs also, the by default applications running as a containers, the application is sending the logs to the std out and std error. That std out and std error logs are generated by applications running in a container that will be stored in this var log containers. Again, it will take that, even though you don't give this also, even though you don't give this also, it will take. But if required, lot of locations you wanted to take, again, you can do lot of customization. Suppose you wanted to take some logs from, like, just I'm giving like this, your system logs, something like this, you can do settings. But this file bit settings, right, you can understand by learning file bit settings, where you can do, right? Configuring file beats. Similarly, fluentd little different. So inputs from where, like input section. So input section from where, like system logs, like this. From what and all locations you have to take, like that. You can define all these things, inputs, right? Input from where you can take. Even this file beats can take the input from CloudWatch also if required. From CloudWatch also directly it can take if required. Like that, this input section, output section, that is like a settings. So if required, you can go with this custom settings also, but already it is there. I'm not using this. If required, you can use like this also, different location. But suppose you have some logs generated by some application in some folder, by default it is not going to there. Just to give an example, let's say you have a your some logs, system logs in some location, it is there. You can configure from which source it has to take the logs, like that you can do. But I am just going with the default only because it is already going to collect container logs. But based on these requirements, you can configure these inputs, outputs also based on your requirement by creating a custom values file like this. By creating a custom values file like this is a separate value file. You can use this separate values file for Elasticsearch, this file bit, and you can deploy with this values file like that. For now, I am just deploying without this values file also. Otherwise, you can create a separate values file like this. Based on your requirement, you can do a lot of customization here. Save this as one file, like maybe just to give an example, you save this as a file, file beat values .aml, like that. So you can use this YAML file. You can use this YAML file with Helm install file beat. This is the Helm repo. This is the values file, like that, and which namespace, like that. You can do like this also. But for now, I am not doing this because it is already there, right? So you can do this type of customization. Without this, let me deploy that file beat in that namespace. Right? Already there is a Helm chart. Let me deploy that. That file beat also I have deployed. Helm. That file bit is going to be deployed as a daemon set. That file bit is going to be deployed as a daemon set. Helm ls in EFK namespace. So you can see there is a file bit also, Helm status, or you can use kubectl get all also. Helm status file bit, Helm status file bit -n EFK namespace. You can see this is deployed as a daemon set again. If required, you can see here itself, file bit is deployed as a daemon set. In each and every node, this agent is deployed. That agent is going to collect the logs, container logs generated by the applications running in a containers on that Kubernetes pods, like that. And that logs will be sent to the Elasticsearch. Now Elasticsearch is there, this agent is there, collecting the logs and sending the logs to the Elasticsearch. Now there is a Kibana. So the Kibana I am going to deploy. But Kibana I wanted to access from outside. So for Kibana, I can create a ingress rules also. I already have a ingress controller deployed. I have used Nginx ingress controller, and I can create an ingress rule, and I can, as per that ingress rule, I can access that Kibana also from outside. So in previous sessions, we discussed about what is ingress controller, ingress rules, what is that, how it will work also we discussed. So already I have a ingress deployed in my cluster. So you can see ingress controller I have deployed in this namespace, nginx ingress controller, and there is a ingress pods running. There is only, this is the only load balancer required, and no need to have a separate load balancers also. If required, if you don't have a ingress controllers also, you can still go and use node IP, node port services if you are familiar with Kubernetes, right? That concept, but I'm trying to show real production level kind of a scenarios, production level kind of a setup, right? All these things, even though I'm taking a sample application, but the what I am teaching here, it is a production grade as use cases, production grade scenarios I'm trying to show. Now let's say I will deploy, but I have a values file also for that one. I have a values file also, so I can create only ingress rules for Kibana. Suppose if you don't know also, we already discussed about Helm default values. Let's say I will use I will see the default values of Kibana before deploy. So here this is the default values. If required for Kibana also, if you wanted to request less, Kibana also, if you see 100 millicore, 1000 millicore, it is requesting production time, okay. But again, this is a separate values file. And not only this, here I will request maybe less, because if you don't have so much CPU, so much memory, then it is a problem. For now, let me use 1 GI. Limits, okay, fine, leave it. And not only this, I wanted to create an ingress rule. So already there is a Helm values, but they have a ingress rules disabled like that. You may see somewhere. This is values file. So what I will do, in my own values, I will make the changes. So ingress enabled true, and path specific, path type prefix. We already discussed about ingress also, and let's say kibana.rushitechnologies.com. I am mapping like this. This is values file, our own values. With this, I will create a values file. Kibana values. Remaining thing default values. Only few things I am changing like this. Now let me use this values file. Let me use this values file, and I will deploy. I will deploy something like this. But here I I don't change to the node port or the load balancer, but because now I am using ingress, so here I will use like this. If required, you can change the service type to load balancer, but that is not recommended for every service type load balancer like that. So I'm going with ingress. Already I have an ingress. This Kibana values.yaml, and in this namespace EFK NS. Now the components got deployed. So there is a agents. There is a agents which is going to collect the data. What data? Logs data. That is Filebeat. The Filebeat is deployed as an agent. It is going to collect the data, log data, and that Filebeat is going to send the logs to the Elasticsearch. Elasticsearch will index and store the logs, index the logs, and store the logs in a central location, right? And since this Filebeat is deployed as a daemon set, maybe in tomorrow you have some new nodes created and some pods deployed on that new nodes. Again, that applications generating the logs. Again, the Filebeat is deployed as a daemon set in each and every node. Again, that Filebeat will be added. That agent-based software, log agent, similarly monitoring agents. So there is a central place where it is collecting the logs and querying the logs. We can do that. Now I have deployed Kibana. So Kibana username is the default username is Elastic. Kibana default username is Elastic. The password you can take this from secret. So this secret. So you can take the password of Elasticsearch. I mean, say the default username is Elastic for Kibana. The password is this. So you can get the password from the secret. But I have already created an ingress rule. Ingress rule. But with this name, I have not mapped my ingress load balancer. So if I go and try to access here, it will say not found like that. If you don't have a real domain, you guys can use the local host file, as I already said. As I already said, as I already said, local host file you can use in regular sessions I said. But I have a real domain. In AWS sessions, we discussed about this Route 53. And in this Route 53, we created a hosted zone. In this Route 53, we created a hosted zone for my domain. Already we created a hosted zone. I will just create a record, alias record, like a Kibana dot this rushitechnologies.com. I will map this to the load balancer created for that Nginx ingress controller. So request will go to that external load balancer. That external load balancer will internally forward the request to the ingress controller pods. As per the ingress rules created for this Kibana, the service will forward it to the Kibana pods. Now let me refresh this. You should see Kibana homepage in just some time. But we are on HTTP, not on HTTPS. So let me use. But it is fine not to bad gateway, because maybe Kibana pods are not still ready, because we don't have enough nodes. Maybe let's see kubectl get all -n efk ns. So because maybe this is still pending, this Kibana pod is still pending. Maybe for this one there is no node. Maybe since we have a e-case with auto mode and carpenter embedded, that will create a node. But if you don't have a capacity, if you don't have a service quota for more CPUs, your AWS will account will not allow. But if you are not able to do that also, maybe at least you can understand how things works here by looking at this video, right? But I have a more quota. I requested AWS to have a more CPUs allowed to use, right? So maybe one more server will be created. You can see one more server is created just now. And again, in that server, EKS auto mode with Carpenter, now you can see Kibana pods are getting created. And again, the file beat deployed as a daemon set. You can see the file beat also getting deployed in that new node. Because maybe in that new node, any application pods deployed, that file beat will collect the logs from that system, application logs, container logs, so whatever as per that input you have configured for file beat. So this is how everything will be working. So let's wait for this container to become, this part to become ready. So now request is going to Nginx ingress controller, but Nginx ingress controller is having a rule, but there is no pod because that pod is not ready. That's why this is giving 502 bad gateway, right? Nginx ingress controller. Once this becomes ready, then this service, this Kibana service will have an endpoint. That endpoint is your pod endpoint, like that. As of now, I deployed with only one pod. This Kibana is deployed as a deployment. Maybe instead of one pod, you can go with the two pods. And Elasticsearch is a stateful application again because it is storing the logs. So it is deployed as a stateful set. This file beat is a daemon set agent, like that. So we discussed about for what purpose you can use deployment, what purpose you can use stateful sets. Also, all these things as part of regular sessions. Now, this is the namespace where I have my log related components deployed. Now let's access. This is my Elasticsearch, right? The default username is Elastic. Default username is Elastic. The password is from this secret. If you lost this command also, you can simply execute helm status, helm status Kibana, helm status Kibana, helm status Kibana. So it will show that again. So make sure your Kibana parts are fine. Retrieve the Elastic user's password. Username is Elastic. Password you can retrieve from this command, like that also they're saying. So this is my password. Username is Elastic. Let me go with this. This is Kibana I'm accessing. But that file beat and Elasticsearch we don't need to expose to outside. That is internal only. But this Kibana is internally talking to the Elasticsearch. Now here you can see here, this is the home page. Now what you can do here in the right hand side, left hand side, top navigation, you can see there is a menu. Here you can see the logs. You can click on logs. Already it is collecting logs. Already it is collecting logs. You can see there are a lot of logs. You can see the logs from which place, what message, like that you can see. But let me deploy one application. Let me deploy one application. And again, you can filter the logs based on the pods. There is something called index. There is something called index. So already there is an index created by, already there is one index created. If required, you can create a custom indexes also. So you can see, you can use some kind of a conditions also. If I wanted to know logs of a specific pod, let's say there is something called a pod, like that. If you see pod name, so let's say pod name is equals to so and so. Let's say even it is Nginx ingress controller logs also collected. Nginx ingress controller logs also collected. You can see here. So if this is the pod name, I wanted to see the logs. Let's press search here, just like this. Plus search. It is only showing the logs of this pod. You no need to say kubectl logs, like that. So here itself, like there are a lot of conditions. Let me deploy my own application also. If it is not deployed, I think I have already deployed one application, our own application, that student registration application. Let me show that. I think I have already deployed. In the previous sessions, we used Helm chart. We developed our own Helm charts actually. In my previous sessions, I have used my own Helm chart. I think in this namespace I have deployed my own application, whether you are, yes. So for this one also I have created a ingress rule, and I let me access this application. I have created an ingress rule also for that. Already it is, everything is in place. Student rich.rushitechnologies.com. This is my application. Now, when this application is deployed in the cluster, we are accessing. Let's say you are a student, you are accessing, you are trying to enroll. But when you are enrolling, something is failed. Let's say when you are accessing this, right? You are trying to give all these things. When you are clicking on register, it is getting failed. Some error or exception is coming. But for now, let's imagine this is going to work. Now I got something like this. But imagine there is something went wrong. So this application already developed by application team. This application already developed by application team. I have already built this application as a containerized application. We have created a Docker image out of this application using this Docker file. With the help of this Docker file, we already created a image, and we pushed that image into some registry, and we deployed that application also into a Kubernetes cluster using deployment services and ingress rules like that. We have already done. This is an application. Think of an end user. So you guys also, as an end user, you are accessing this and something is getting failed. Let's say something is getting failed. Somewhere it is getting failed, right? Maybe that application team has to troubleshoot. So what we can do, you no need to go and check if there is any issue. We don't need to go and check kubectl logs on this, kubectl logs on that, like that. You no need to check like this. So already there is a data collected by that, there is a logs, these type of log messages. These are like a log messages. These are like a log messages already generated by my application has a log statements. I have already shown that. So this is application that development team already has log messages. This using log4j. These are sent to the std out and std error, and again it is collected by filebeat collecting these logs, and it is sending to the Elasticsearch already, right? So you no need to go and check each and every pod like this. One pod, two pods, fine. But again microservices, and again one microservice communicating with other microservices, and again these pods are distributed to so many. In one pod I don't see like that logs. Maybe in another pod again I have to see like. So this is successful for this person, this is successful. But like one pod, no, I don't see another pod because request went to another pod. It is very difficult to check all these things. Suppose I can search also with this pattern whether request reach a particular. That is based on what you have added, guys. Suppose in the application there is a message. In this application there is a message. There is a message. So I can search based on that. So now let's say I will go to my Elasticsearch. So here I can search also with that pattern. Let me say press enter. Let me say press enter, or maybe let me remove with without space. Let me search with the Balaji, only Balaji. Let me search with this pattern. 1 second. Let me search with Rushi. 1 second. Or let me search with the pod name. Pod name. Pod name equals to. It is not search. It is not showing that pod. So 1 second. 1 second, guys. Let me see 5 minutes back like that. Here up. Let me apply that filters. It is taking time. Actually it is taking time. It took some time actually. So fine, because it is going to take some time. Just now we have deployed quickly, right? So let me search with this Balaji. Just search with the Balaji like that. So it will show like this, whatever. Maybe let me say like 10 minutes, or last 15 minutes or 10 minutes like that. So performance wise it is little slow because I have requested, I have given less CPU and memory. It is taking some time. Here it is showing, but it is taking some time. It is taking some time. Let me say just 10 minutes back, or you can customize last 5 minutes, last 15 minutes also like that. So it is showing Balaji wherever it is, see, wherever you see Balaji, it is showing. So this is message, log message, log message. So this application like that. If you wanted to see more details, if I click on this view details, it is going to show so much information. So from which from which container it is find that logs, right? Container details, node details, your deployment name, all this information also collected by that logs file bit, and it is sending the details. So this is the container, this is the log, find in that container log. In this var log containers, automatically logs will be generated from there, it is sourcing like that. This is the message like that. Suppose you wanted to search with some error, let's say there is any error like that. So like this you can do. There is no errors as of now like that. If there are, suppose somewhere you see 500 code, 200 status codes like that also you can see. Let's say 502 bad gateway, 502 bad gateway, or these type of errors also if you wanted, you can see. Suppose you wanted to go with multiple also, pod name, like let's say pod name is equals to this, not equals to this, pod name is this, and a message, and a message, and a message, message is something like, suppose a message has something like, you can see error, these type of errors, these type of things. If you wanted to search also, you can search. This is only Nginx ingress controller ports, Nginx ingress controller ports. So if you wanted to see, this is like a pattern, right? You can search with this pattern also, 302, 502, whether is there any 502, 302 status, 500 status, like that also. So all the request is coming to the Nginx controller. That Nginx controller is going to, ingress controller is going to send. You can search with these patterns also, message, message, like anything message like this. And you can use regular expressions also. Is there any request came to so and so API, you can search like that. So when request came, these logs are generated by your applications, and we can query the logs and index the logs. Not only this application, let's say any other application, not only this application, let's say any other application you are trying to deploy. I have so many applications. Let's say I have so many applications deployed here. Let's say I have so many applications deployed here. Maybe let's see, I can deploy any other application, student management application, student management app, where I have deployed that stateful set as a stateful set. So I have a one more application. Let me deploy that application. Let me deploy that application. Somewhere I have taken that as a backup. Yeah. So let's say I am going to deploy one three-tier application. I am going to deploy one three-tier application. There is a database, there is an application, right? Uh, that database again I will try to deploy as a stateful set in my Kubernetes. So this is application, right? So this I'm going to deploy the database as a stateful set, Mongo database with the primary DB, secondary DB. This we have discussed in a regular session. Let's say Mongo DB stateful set. I'm going to deploy one more application. This application is a typical three-tier application. First database also I'm trying to deploy as a primary DB, secondary DB. But if I don't have enough CPU and memory in these nodes again, it may take some time. Let me deploy this stateful set. And first I have to configure this primary DB, secondary DB database replication. So this is also already uploaded in our YouTube channel, right? So what is a stateful set? How we can deploy Mongo database like a primary DB, secondary DB? This video I'm talking about, right? We discussed here. But here only few things only we uploaded in our YouTube channel, but detailed way we have discussed in a regular sessions only. So let's say kubectl get all -n. In this, I have a databases getting created as a primary DB, secondary DB like that. Let's wait for all these things to come up. Then we will set up the primary DB, secondary DB concept. That is nothing to do with Kubernetes. That is nothing to do with anyhow. That is nothing to do with Kubernetes or Elasticsearch like that. So that is a normal, database concept. So in the previous sessions, regular sessions, we have already done that. So let's deploy. We have deployed the stateful set, and once that is done, we will set up the primary DB, secondary DB like that. We'll set up that primary DB, secondary DB like that by going once, one of the pod. But let's wait for this. I am trying to deploy one more application. This Mongo database pods are getting created. I will set up a primary DB, secondary DB like that. We discussed in a previous sessions actually. Now for this one again, Carpenter will create. Maybe in your clusters it is not possible because your AWS accounts may not have a limit, may not allow you to create these many servers again because of the service quotas. But even though you are not able to do it when you are practicing, maybe at least you can understand the things with this session. It will take some time. That Carpenter to create additional nodes, it will take some time. This is obviously because of that only. We discussed already all these concepts in regular sessions. kubectl troubleshooting also very important. Describe. So this is because of no available nodes, right? But maybe it will try to create because of that Carpenter with EKS auto mode. It takes time. It takes time. Let's see. It is still pending. Now it is getting created because the Carpenter has created some new node, it seems. Now you can see some new node has been adjusted. Maybe something adjusted, it is created. Now this another replica of my database also getting scheduled. And let's wait for this also become ready. Then we'll try to set up a primary, secondary, that is database concept. Now let me go inside one of the database pod. I will try to set up primary DB, secondary DB. So I'm not getting too much here because this is already discussed in our regular sessions. So let's connect to the Mongo shell. We discussed all these things in a detailed way. Let me set up the primary, secondary setup, and let me configure a database with some username and password. So 1 out of 3, 1 will become a primary after some time. This is primary, first one. Now let's protect the database with some username and password, right? With this database setup is done. Now I will try to come out of the database shell, container shell. Then let's go and deploy application. This can be deployed again via Helm charts also, via Helm charts, right? And again, for this one, I will create a ingress rules also because I wanted to access, I no need to have a load balancer. So let's let it have cluster IP for this application also. And let's leave this. I will create a ingress rule. This can be deployed via Helm charts also. This is name of my ingress like this. Ingress rules, ingress path. So my main domain I will map to this. My main domain I will map to this. So here, if a path is route this domain rushitechnologies.com, if this is the path route the traffic to this service like that, this is my service name. This is my service name, right? We are doing like this via ingress, right? This domain I will map with my ingress load balancer. But this application talking to the database, I am giving the database service details, username, password. This is we already discussed. Let's leave this. I'm just trying to show if this application is also generating the logs. Imagine this application is also generating the logs. So you no need to go and check in each and every log pod like that. These logs also will be collected by this logs also will be collected by that Filebeat and send that logs to the Elasticsearch via Kibana. Via Kibana, you can query as an application team. We can query the logs. Let's do this. Let's say I have deployment. I have service. I have a ingress rule. Fine. Let's deploy this kubectl apply -f student management. Now let's see again, this is also deployed. This can be deployed via Helm also. Fine. Student management. This is another application. And I have created an ingress rule also for this application. The via that ingress rule, this domain mapped with that service like that. But let's map this domain in Route 53. That is a different concept. So let me map the main domain. Let's map this main domain with that ingress load balancer. I'm not using any subdomain concept here. The load balancer created in a Mumbai region where I have a cluster with this create records. I think there is already a record. As part of previous sessions, I have already done. I already have a record. I already have a record, right? I already have a record for this already. So it is pointing to the same ingress load balancer. Anyhow, fine. But let's wait for this pods to become ready also. Now this is one more application. Let me access via that domain, main domain, that is another application, Rushi, double I, Rushi. This is just for testing purpose. I am having one more domain. But our official website is rushi technologies.com, rushi Rushi Technologies. This is for my training purpose. I mean to say my company purpose. But for training purpose, same only, but there is a double I. That is what I am using, rushitechnologies.com. Now this is what I have mapped with that. This is my application, one like a student registration. So this is one application where I can add the students. I mean to say you guys can register yourself like that. Just to give an example, this is one testing sample application in real time, real application. But application doesn't matter here. The concept is same. This is typical three-tier application. This is a typical three-tier application where there is a presentation layer, there is a UI, right? There is a UI, there is an APIs. This UI is internally making a request to the API. That APIs are internally talking to the database. Suppose somewhere this is getting failed. Somewhere it is getting failed. Let's say I'm somewhere while somewhere when they are accessing, it is getting failed. Just to give an example. So that application team need logs. They no need to go to each and every system, each and every pod like that. So they can easily query the logs. If this is also generating the logs, if this application is generating the logs and that Filebeat is collecting the logs, they can see this. Suppose while creating, while viewing, there is a issue while updating. Let's say they are updating something. While this is it is getting failed like that. It is getting failed somewhere like this. Suppose somewhere it is failed like this, right? During update or during delete, it is failed. So wherever there is a errors or exceptions occurring, right? You wanted to see like that. So sometime back error happened, right? So you no need to go to that each and every pod like this. So this is application. So you no need to go to kubectl logs like this. And these logs are collected. You can see there is some errors or exceptions happened for some reason, right? So you no need to go to this type of things. Here you already have a log aggregation in place. So here you can search also with the patterns like a error, there is some error, exceptions like that. Suppose there is a errors or exceptions like this, you can search with this type of keywords also, exceptions, errors, something like this. Just to give an example. Or pod wise, container wise also you can search. Let's say with this I can search exception like that. Exceptions, wherever there is a keyword with exception, it will try to show. Again, last 5 minutes only wanted to show, right? You can say last 5 minutes only I wanted to see. So in last 5 minutes, last 2 minutes, like that. Last 5 minutes, last 2 minutes, like that. Let's say last 5 minutes, last 2 minutes. Also, you can search like this. Last new entries. It is trying to search also with this. Otherwise, you can search with the particular pattern. If that is logs are being stored. Again, that application should log that messages. I think this is student management app. I think there is a logs added log statements. Let me see. Not this test main. This we already used. Yeah, log messages are there. Student found, student not found. Like this, log messages has been added. Right? You can search with this pattern also. Search with this pattern also if there is a request went to this or not. So you can search like this text pattern also. You can search with this text pattern also whether request went to that this or no, like that also you can stream the logs. But performance wise it is slow because I have limited only given less CPU, right? In real time you have to use more CPUs. You have to use more CPUs, right? So more CPUs you have to use, right? Let me do like this. Let me see with this text pattern. Is there anything? Let's say last 5 minutes. Like last 5 minutes, last 10 minutes, like that also you can say. From yesterday to today, what happened, like that also you can apply all these things. 5 minutes, 10 minutes, like that also. Let me search with some pattern like this. Otherwise you can see something like this also, pod name wise. Pod name wise also, let's say pod name or deployment name. Let's say there is a deployment. Deployment has a multiple pods. Deployment has a multiple pods. Let's say the deployment name is this one, student management app. This is one name. Like then it is going to let me remove this. Let me come out, just come out here, right? Press enter. It is going to search the logs, right? It is going to search the logs, but it will take some time. It will take some time because I have given less CPU, less memory, like that. So it will take some time. Suppose let's say Kubernetes deployment, the deployment name, other application deployment name is equals to this one. This is one more application, right? Let me press here. Let me press enter. It is going to search the logs. But again, if there is no new entries, If there is no new entries here, right, it will try to search, it will try to show. If it is not there also, it will check. You can click on this all these options, and you can use also like this. So this is basically logs, log messages, right? Let's say you wanted to search with some particular pattern. Like this also you can search last 5 minutes today. Like that also you can search. But it is taking time because we have given very less CPU, right? Very less CPU, very less memory. So when you are working in real clusters, you are going to have a more CPU, more CPU, more memory. So you can go to logs, you can query the logs. Here you can see there is a errors or exceptions also. It is, you can see here. Now you can search, again you can search, right? Suppose deployment name is this, deployment, Kubernetes deployment name equals to this deployment. Now it is taking time, but you can see the logs of all the pods belongs to the deployment. You can see, even though this deployment has 2 3 pods, 4 5 pods also. And again you can see some errors, exceptions, hack no happened. So you can see more information about this also. What is this, like what is the like error? You can see here, okay, there is some error, it is having some problem to connect to the database, like that. It is like that. You can see these type of errors also. You can troubleshoot, debug, and identify the problems. So here you can search with some patterns like this. Search with some patterns like this. Wherever you see Rushi, it is trying to match. Suppose similarly there is something called Balaji, right? Here this deployment or this application, this is where you can see Balaji, like that. So you can track logs, right? So this is very very important concept with respect to debugging and troubleshooting, right? So Prometheus and Grafana, that is system monitoring and application monitoring. This is also log monitoring and log aggregation, right? I hope you got a detailed information about what exactly this monitoring, log aggregation and log monitoring. With respect to log aggregation and log monitoring, what is Elasticsearch, what is Kibana, what is maybe Logstash, or maybe Filebeat or Fluentd, you can understand. Or maybe with respect to system monitoring and application monitoring, Kubernetes cluster monitoring, what is Prometheus, Grafana, we have discussed as part of the regular sessions already, right? So this is going to give a complete overview so that you can understand all the concepts when you are working for any applications or projects like that. I hope everyone enjoyed this advanced training from Rushi Technologies, right? So that's it for today's session, guys.